Hi everyone, welcome to day 7 of Just Enough Python for AI. With today's session, we are moving to a new module which is on NumPy. As we have discussed before, AI as a field has a lot of mathematics. And when there is mathematics, obviously there are numbers. And NumPy as a library helps us with numbers. It makes handling numbers in Python much more efficient and much more quicker. Hence, it's a very important library, and I would say, starting with NumPy, we are slowly moving away from core Python and moving towards Python that is specific for data science. Let's get started. Today, we will understand why NumPy is critical for data science, how to create and manipulate NumPy arrays, and arrays are the building blocks of AI. The basics of array operations, indexing, reshaping, and slicing. So what is NumPy and why do we need it? Why not just use the native Python list? You might be wondering, why not just use the Python list, the native Python list? Why do we need NumPy as a separate Python library to deal with numbers? Python lists are versatile, but they have some limitations. The first is inefficient memory use. Now, lists store references to objects, wasting memory. Let's not go into the technicalities, but just understand that it is a lot more memory efficient to use NumPy. Lists are also slow for numerical operations compared to NumPy. And list does not support advanced mathematical operations. To do something like matrix operations, you will need to write additional lines of codes or use different libraries. That's where NumPy comes into the picture. NumPy, which is written in C, is much faster than lists for numerical operations. NumPy arrays also require a lot less storage than Python lists. Also, NumPy has built-in functions handling linear algebra, statistics, and data wrangling with ease. And the most important, NumPy allows you to do array operations without writing loops. NumPys are a lot more efficient with arrays. So let's get started. If it's the first time you using NumPy, you will have to install it. I already have it on my machine. That's why I'm getting a message requirement already satisfied. Now let's make our first NumPy array. Now a NumPy array is like a list but faster, more compact and designed explicitly for mathematical calculations. Before you can use NumPy, you will have to first import NumPy. Now let's create our very first one-dimensional array and two-dimensional array. Let's see what we mean by one-dimensional and two-dimensional. One-dimensional basically meant that we just had one row of elements, while in a two-dimensional array, it's more like you have both columns and rows. So we have 3 columns and 2 rows. Let's go through the code a bit in more detail. Now this is how we create a one-dimensional array. We are first giving it a name, array_1d, and then we say np.array. .array is a NumPy built-in function that we use to create arrays, and then within square brackets we are giving all the elements that should be in our array. Here we are giving 1, 2, 3, 4, 5 separated by commas. This is all you need to create your first one-dimensional array. Now let's look at how we create a two-dimensional array. The structure is pretty much similar. We are first giving a name, array_2d, then again np.array. The only difference that you see is right here. We separate our rows with a comma here, and each row is enclosed in a square bracket. So we have 1, 2, 3, which is your first row, and then 4, 5, 6, which is your second row, as you can see here. And this whole thing is again within a outer square bracket, which denotes the array. Now let's look at the differences from a Python list. We are first creating a Python list with elements 1, 2, and 3. Then we are also creating a NumPy array with the same elements 1, 2, 3. And what we want to do, we want to add 2 to each elements. So we want to add 2 to 1, 2 to 2, and then 2 to 3. Same with the arrays as well. Your final array, your final list should be 3, 4, 5, and your final NumPy array should be 3, 4, 5. Now, the way to do it with NumPy is very straightforward. As you will see here, we will simply say NumPy array plus 2, and this will add the 2 to each element. But you can't do that with the Python list without looping through each element. For the Python list, you'll have to first loop through each element, and then you'll have to add 2 to each element individually. You'll have to write a for loop to do this addition. But for NumPy array, you can simply say NumPy array plus 2, and this small piece of code does the addition on each element of the NumPy array. You don't have to go through the list. You can simply say NumPy array plus 2. This will add 2 to each element. Let's get it working. This message that you are seeing is simply a part of my text that I'm giving. I'm just trying to say that if you do this Python list plus 2, it will give you an error. Instead, you need to do this. And to just confirm whether we'll get error or not, let's just try to do this line where we have Python list plus 2. I'm going to comment the other 2 lines, and let's see what happens here. We do get an error. You cannot add 2 to a Python list by just simply saying the name of the Python list plus 2. It will give you an error. Let's comment this line again. So that's the very first difference that you saw, how easy it is to do an array summation with NumPy, while it is a lot more difficult to do the same thing with a list. You'll have to write a for loop to go through each element of the list and then add to each element separately, individually. Now let's look at NumPy advantages, the most important being array operations. Now with NumPy, you can perform operations on entire arrays at once. An example of that we just saw, we did a sum of 2 on the entire array at once. And this is how you can do. We saw this example already. We are adding 2 to each element. Here we are multiplying by 3 to each element. And we are also doing a square of each element. And let's execute this code. And you see that with arrays, we are able to do this operation on the entire arrays at once. We don't have to loop through them. This makes working with arrays a lot more easier. We can also do array comparison. Let's see what we mean. So our original array, which is this array, is still 1, 2, 3, 4, 5. If you are thinking that these operations change the value within array, then you are wrong. We are simply printing the values of these operations. So array plus 2. We are not changing the array by itself. Our original array still remains 1, 2, 3, 4, 5. If you print simply array, even here, let's just print somewhere here. You'll see that our array is still 1, 2, 3, 4, 5. And on that, we are checking if the elements of the array, when we say array greater than 3, we check each element of the array if that element is greater than 3 or not. And again, here we are saying if array is equal to 3 or not. So we are checking if each element of the array, which is 1, 2, 3, 4, 5, whether these elements are equal to 3 or not. And what you get here is a Boolean output, true and false. So if you see array greater than 3 will result in this being false because 1 is not greater than 3. Same with 2, same with 3. But 4 and 5 are greater than 3. So you'll get true for these two. And that is what you see here, false, false, false. These 3 are false. And then you have true and true. And again, when you check if array is equal to 3 or not, 1 is not equal to 3, 2 is not equal to 3, 3 is obviously equal to 3, and then 4 and 5 are also not equal to 3. And hence you get false, false, true for 3, and then 2 more false. So again, what you saw here is that we are able to do comparison over the entire array at once. That's so amazing, right? You don't have to loop through them. You don't have to write a few lines of code just to loop through them and then compare the elements individually. You can do it all at once. Now let's understand array dimensions and shapes. Now, while working with multi-dimensional arrays, it's very important, it's very critical to understand the shape of the array. We have already seen these two examples of one-dimensional array and two-dimensional array. Let's first execute this cell and then we'll see what we mean. So, this is how you will see the shape of a one-dimensional array. We have 5 elements here. So we are seeing 5 comma nothing. For two-dimensional array, we have first the number of rows and then the number of columns. And I believe a lot of you would think if we are representing two-dimensional array with the rows comma columns, isn't this wrong for one-dimensional array? For one-dimensional array, if you see, this is basically the one row and then we have 5 columns. So why don't we represent 1 comma 5? Why do we say 5 comma nothing? This is quite interesting. It does confuse a lot of people in the beginning that why a one-dimensional array is represented like this. This looks as if we are saying this one-dimensional array has 5 rows and no columns. While for two-dimensional array, it looks like we are saying 2 rows and 3 columns, which is true. We do have 2 rows and 3 columns. It's this one-dimensional array that makes people get confused. Try to figure out why it's like this, especially one-dimensional array, why it's represented like this, why one-dimensional array and two-dimensional array are not represented in the same way. You can maybe ask ChatGPT or even any other favorite LLM, Gemini, Grok, whichever one you like. I'm pretty sure you will be able to figure out, but I will leave it up to you guys. But yeah, this is how you represent the shape of one-dimensional array and then two-dimensional array. You can also print the dimension of the array itself. So for this array underscore 2D, we are trying to find the actual number of dimension, and it says that our array is of 2 dimensions. Then we are trying to find the size of our array. Size of our array is nothing but the count of elements, all the elements which are there in our array. How many elements do we have in our array? We have 6, and that's what we are seeing here. Next comes reshaping of arrays. So what we mean is that we can reshape the dimensions of the array. So one-dimensional array could be reshaped into a two-dimensional, or a two-dimensional array can be changed, can be reshaped to a one-dimensional array, or any other. We can even reshape a one-dimension to three-dimensional array, and so on. For that, we will use .reshape method. So we have a one-dimensional array, and then here we are reshaping our one-dimensional array into a two-dimensional array with 2 rows and 3 columns. While here we are then reshaping it, the two-dimensional array that we created here, to a one-dimensional array again. Let's execute it and see how it looks. So this is our first array, 1, 2, 3, 4, 5, 6, one-dimensional. We reshaped it to a two-dimensional array with 2 rows and 3 columns, which is what we did here with this line of code. And then here we are now flattening our two-dimensional array, the one that we created right here, and we are using another method ravel to flatten this two-dimensional array into one dimension, and then we get what we originally had here. And before we move any further, I wanted to give an example of three-dimensional array. If we could create one-dimensional and two-dimensional array, it's, I think, pretty obvious that we should be able to create three-dimensional array as well. And this is an example right here. So what we are saying here is same syntax. We have given a name, then np.array. How do we interpret this? This is how we create a three-dimensional array. This array has three dimensions. There are two blocks, first block and then second block. This is your first dimension. Now within each block, this is your first row and this is your second row. So this is your second dimension. And then within each row, you have three columns. That's your third dimension. We can also think of it in terms of x, y, and z axis. I will leave it up to you guys to put your brains and try imagining a three-dimensional array. It should look something like a cube of numbers. Let's execute this code and see how it is. So as you see here, number of dimensions is 3 and the shape is 2, 2, 3. So this is your first dimension, this is your second dimension, and this is your third dimension. So we have two blocks, each block has two rows and each row has three columns. Two blocks, that's what we have here, 2. Each block has two rows. As you can see, we have two rows. Each row has, each block has two rows, and then each row has three columns. Now, a question for you. We saw one-dimensional array. We saw two-dimensional array. We also saw that three-dimensional array exists, even though we are not doing any operations on three-dimensional array. It's a bit more difficult to grasp the concept of three-dimensional array unless you have mastered two-dimensional array. So we are not doing any operations on it, but yes, every operation that you could do on 2 dimension can also be done on 3-dimensional. The question for you is that, do you think there are possibilities of arrays with even higher dimensions? Can we have 4-dimensional array? Can we have 5-dimensional array? Can we have n-dimensional array? And if so, if there is a possibility of a higher dimensional arrays, what is the use case of it? Where will you use a 4, 5, 6-dimensional array? That's the question for you. Put down your answers in the comment box. Now let's look at indexing and slicing. If you remember list, we did indexing and slicing on list as well. The same applies on arrays. So what we are doing here, we are first creating a one-dimensional array, which is pretty similar to list, one-dimensional list, and then we are trying to access the element with index 0, which should be 10, and then we are trying to access the element -1, which should be the last element, that is 50. And here we are creating a two-dimensional array, the first row being 1, 2, 3, and the second row being 4, 5, and 6. And then here we are saying let's try to print the element at row 1, column 2. Now do remember that even with two-dimensional array, the indexes still starts with 0. So when we say element at row 1, we mean the second row, because the first row is still index 0, but we are saying 1. So it should be second row. This is your row 0 and this is your row 1. Then within that row, we are saying column 2. Again, we have to start counting from 0. So this is your 0, this is your 1, and this is your 2. So when we say the element at 1, 2, row 1, column 2, we should get 6. And here we are simply printing all the elements of row 1. Which one is row 1? Not this. This is row 0. This is your row 1. Let's execute this code and see how things look. So as we discussed before, this array 0 is printing the first element. This array -1 is printing the last element here. And then this element 6 is your element at 1, 2, where is row 1, column 2. This 6 is that element, and then here we are printing row 1. Row 1 being this, not this. Now let's look at slicing. Now slicing allows you to retrieve subsets of your arrays. So let's first execute this code and see how it works. So here we are first creating an array of 5 elements, 10, 20, 30, 40 and 50. And then we are trying to print from first to third, that is 10, 20 and 30. First, second and third. Do remember again that the index starts from 0. So we want to print index 0, index 1 and index 2. So for that we say array and then within square brackets 0, then colon and then 3, not 2. 3 because we saw it before, even with strings, even with lists, that the last element is not included. So when we say 3, the element at index 3 is excluded. It will print 0, 1 and 2. Elements at 0, 1 and 2, which is what we are looking for. So you have 10, 20 and 30. Then here we are trying to create again a two-dimensional array. The first row being 1, 2, 3 and the second row being 4, 5, 6. And then here we are trying to print all the elements of the first row, which basically means all the columns of the first row. So we'll say first row, the index for the first row is 0, that we know. And then we simply say this from 0 till the end. When we don't assign anything before or after colon, it basically means everything from the first till the last. So this is the output of this line. We are printing all the columns of the first row, which is nothing but the first row itself. So we print all the columns of the first row, 1, 2 and 3. Now let's look at this line. Here we are trying to print all the rows of the first column. If you imagine this this array, this 1, 2, 3 and then 4, 5, 6 in a say in an Excel sheet, what will be the first column? The first column would be the first element from row 1 and the first element from row 2, 1 and 4. So we are printing the first column as 1 and 4. That's what we get here. This is slicing on arrays. Now let's look at fancy indexing and Boolean mask. Let's first look at fancy indexing. So in all these examples till now, we were either accessing elements, individual elements of an array or a subset of elements from an array. We never specified specific elements from an array. But if that is what is your goal, if you want to access specific elements, for example, if you access this specific elements at index 1, which is 20, and then index 3, which is 40, and then index 4, which is 50, not necessarily everything from index 1 to 4. You don't want, for example, the element at index 2. In that case, you would use a list of indexes. You will pass a specific list of indexes to get your specific elements. Next, we will look at Boolean mask. So you can actually say that only give me the elements that are lower or higher or equal to a certain value. So here we are saying only give me the elements that are higher than 30, that is greater than 30. Let's execute this code and see how it works. So as you see, for this piece of code, we are getting 20, 40 and 50, 20, 40 and 50. And then for this, we are only selecting the elements which are higher than 30. So we get 40 and 50. That is your Boolean mask. Now let's look at how we can create arrays using NumPy's built-in functions. So NumPy provides several methods to generate arrays with specific patterns or values. Here is an example of creating arrays with zeros or ones. And if you're wondering what's the point of creating arrays with values of zeros or one, most often we use it for initializing arrays. So let's execute this and see what we get. Let's look at the first block. Here we are creating an array of zeros. And how do we do that? This is the name of the array that we have given. We can call it anything else. And then np.zeros. This zeros is a built-in function that NumPy gives you. And then we pass the number of rows and the number of columns. And when we execute it, we get an array of 2 rows and 3 columns, all with value of 0. The next block is for array of ones. Very similar concept. Here we are giving the name as ones, the name of the array as ones, and then we say np.ones. Dot ones is a built-in function given by NumPy, and we pass the rows, the number of rows and the number of columns, row comma column. And when you execute, you get an array of 3 rows and 2 columns. So this is how you create arrays with zeros or ones, used most often for initializing arrays. Next, let's look at creating arrays with a range of numbers. So let's first execute this code and see the difference in between these two functions. So the first one is range underscore array, and this is an array with values from 0 to 10, 10 not included because we know why, and in the steps of 2. So we get 0, 2, 4, 6, 8. And the next one is np.linspace, and we are saying that create an array from 0 to 1 with values from 0 to 1. And here we are not saying the steps, but we are saying exactly how many values we need. So we are saying that I need from 0 to 1, 5 values. And that's what it's giving you. From 0 till 1, 5 values. And one thing that you must notice here is that here 1 is included. Don't ask me why. This is how linspace works. When you use linspace, you get starting value, end value included, and you get equal spacing of the number of values. So here we have 5. So we get equally 5 equally spaced values starting from 0 and ending at 1. So we get 0, we get 0.25, you get 0.5, you get 0.75, and you get 1. So these are ways to create arrays with specific sequences. Many times you would want to create arrays with random numbers or random values, and we have ways to do that as well. And very often this is used to initialize the weights in deep learning. So here we are using np.random.rand, and we are saying the number of rows and the number of columns. This will give you random values between 0 and 1. .rand will always give you random values from 0 to 1, and we're just saying how many we want. We have 3 rows and 2 columns. That means we'll get 6 values in 3 rows and 2 columns. And then the next one here, we are saying np.random.randint. When we say randint, we get values from 0 to 10, integers, and we are saying 2 rows and 2 columns. Let's execute this code and see what we get. So with the first one, as you can see, we got values between 0 and 1, and we have 3 rows and 2 columns. And for the second one, we got random integers between 0 and 10 with 2 rows and 2 columns. So 2 rows and 2 columns, while the values are random between 0 to 10. And by the way, for both these examples, the starting point, that is 0 here and again 0 here, is inclusive, while the ending, that is 1 here and 10 here, is exclusive. So it will generate values starting from 0 till 9. And here it will generate values starting from 0 up to 1, but not including 1. But when you print, you will get random values. You may get a 9 here, you may get a 9 somewhere here, but you will never get a 10. Here as well, you may get a 0 somewhere at times if you re-execute this code again and again, but you will never get a 1. This linspace is the only, you can say, anomaly from what we normally know. With linspace, both the starting and the end points are included. So now let's look at the concept of copying versus viewing of arrays. So copying is straightforward when you copy an array into a new array. But viewing is nothing but slicing of arrays. When you create a slice of the original array, you are not creating a new array by itself. This new slice is still linked to the original data. And when we operate on this new slice, this slice of the data, very often we don't realize that we are actually manipulating the original array itself. Let's look at the example and understand. So here we are first creating an array with the elements 1 to 5, 1, 2, 3, 4, 5. And then we say view is equal to array, and we're taking a slice of the original array with starting from 1, index 1, and up to 3 with 3 not included. So index 1 is 2, and then index 2 is this 3, while index 3 is 4, which is not included. So we should get the values 2 and 3. So that's what we got here. Our view array has elements 2 and 3. Now we are saying that we want to update the value of the element at index 0 for view to 99. Now the element at index 0 for view is this 2. We are updating this 2 to 99. And after that, I'm simply printing the original array. The original array is right here. And if you notice, even though we worked on this view, we updated the view array, it also went and updated the 2 here. So you got 99 here. Now the original array has been changed. Even though your intention was to change the value within this view array, you went ahead, this operation actually went ahead and updated the original array itself. When not taken care of or when not intended, this might result in errors or unexpected behaviors. Now, how do we avoid this? To avoid this, we have to do something like this. So here we are saying we have a new array named copy. Copy is a name that we are giving. We can call it anything else. And then array, this is the original array. We are taking a slice of the original array, starting with index 1 and ending at 3. That means 3 not included, ending at index 2. So we will have values from index 1 and index 2. But what we have additionally done here is that we have applied the .copy method. So this will create a new array named copy, which is not linked to the original array. After we execute this line of code, our copy array should have values 99 and 3, because we have already changed this value. So you will not have 2 and 3, you will have 99 and 3. It's better we print it so that we can see, right? Let's re-execute this code. So as you can see, our copy array has values 99 and 3, since our original array was already changed by this piece of code. And then after that, we are trying to update the value at index 0 of copy. And then we are printing the original array. So the original array now is this. So even after you update the value at index 0 of copy, this does not change the original array. While here we unintentionally change the original array. Let's also print the array copy after the change, so that we see that even though the array copy was changed, but the original array was not changed. So you can see the copy had values 99 and 3 before the change, before this update. Now after the update, the same array copy has values 88 and 3, but this did not update the original array from which this copy was created. These are two separate arrays not linked to each other. This is something that you should take care of while you do your own coding. Very often we miss this and then we end up with errors or unwanted changes. Now this brings us to the end of today's video. Arrays are a very important concept. I would request you guys to put some more effort, put some more time, and practice some more questions. I have given some questions right here for you guys to practice. Again, I'm pretty sure all of you will be able to solve these questions. If you have any questions around my questions here, please feel free to put it down in the comment box. I will try my best to reply each one of you. And the last section is the solution for our previous question, the questions that were asked in our previous video. So day 6 exercise solutions. So the first question is, create a greeting function that takes name and age and says, this is the output, hello, and then you will pass the name, you are, your past age, years old. So basically we are supposed to create a function that takes name and age as input parameters and then prints the output in this format. Here is a sample solution. We are defining a function named greet. We're taking name and age as input parameters and we are printing what we need to print. And here we are calling our function with the arguments Babu Rao as the name and age 48 as the age. If we execute this code, we see that we are able to print in our required format. The next question is to write a function to calculate the area of a rectangle with default parameters length equal to 10 and width equal to 5. So here's a sample solution. I'm defining a function right here named as rectangle underscore area. It's taking two parameters with both having default values as well as specified here, length and width. For length, the default value is 10 and for width, the default value is 5. And then we are returning length into width. That's the formula for calculating area of rectangle, length into width. Then we are calling our function first without any arguments. So that means that this function will use the default parameters. The answer should be 10 into 5, that is 50. And the next time I'm actually passing arguments with length equal to 7 and width equal to 3. In this case, it should use this argument and the area should be 7 into 3, that is 21. Let's execute this code and you get values as expected, 50 and 21. Now question number 3, create a function. I've given a name is underscore even that takes a number and returns true if the number is even and false otherwise. So here is my function. The easiest way to check if a number is even or not is to check if the number is divisible by 2 or not. And how do you check if the number is divisible by 2 or not? If the remainder is 0. That's what we are doing here. And then we are calling this function twice, one with the value 10. So this should return true. And the other time we are calling it with value 7. 7 is not an even number, 7 is an odd number. So we should get output as false. So that's what we are getting here. Now let's move to the next question. Our question number 4 was to write a function named process underscore list that takes a list of numbers and first thing removes duplicates, second sorts the list in ascending order and returns the cleaned list. And I would like you to use a lambda function inside the Python's filter functions to extract all even numbers from the list. And I've given a list of numbers that is 3, 6, 8, 7, 5, 9, 2. So this is a bit more difficult question than the previous ones. Those who got it right, very well done to you guys. If not, no issues. We'll just go through the solution and it will make sense. So the first thing was to define a function named process list. So that's what we are doing here. We are defining a function named process list. It takes a list of numbers as a input parameter. So this is our input parameter. This is a list of numbers. We have defined it here. Then the next thing was to remove duplicates. Now we have learned that when you transform a list into set, it removes the duplicates by default automatically. So that's what we are doing here. When we say set and then we are passing our list inside the brackets, it's converting the list into a set which is automatically removing the duplicates. So the next one is sort the list in ascending order. So we are applying the sorted function here. This is in a way a nested way of applying functions. We are first applying set function here and then we are applying sorted function here. So the output of this is fed into this sorted function and then return the clean list. So the output of this is the clean list. Next, we are saying that you must use lambda function and you must use the Python's built-in filter function to extract all even numbers from the list. So now we will use this clean list and we will extract all the even numbers from this list. So here is our lambda function. We are checking if the numbers within this clean list is divisible by 2 or not. And we are filtering those numbers. So if this condition is not true, we do not include that as an output of this filter function. And then eventually we are converting the output to a list. And then eventually we are returning two lists, the first one being clean list here and the next one being even numbers. And we also have some example usage. This numbers is same as we gave here. And then we are calling the function cleaned and evens. So cleaned will have this list and evens will have this list and then we are printing them. Let's execute this code and see. So clean list, as we saw in the question, it has all the elements from the input list without duplicates sorted in the ascending order. So just to clarify, this will always sort in ascending order by default. If you want it to be sorted in descending order, you will have to specify it. And how to specify that? I would like you guys to check that yourself. But anyway, this is our output as expected. The duplicates were removed and the elements were sorted in ascending order as expected. And next, from this list, from this clean list, we extracted only the even numbers. So there is 2, 6 and 8. That's our solution for the last question. With this, we have reached the end of today's video, but we are not done with NumPy yet. There's a lot more to NumPy and there's a lot more to maths with NumPy, which we'll see tomorrow. See you in the next video.